So welcome. These are some past paper questions based upon series and also a bit of induction. So we shall start solving them. The first question, the sequence 7 A B C 31 forms an arithmetic sequence. So this has to be U1, this has to be U2, this has to be U3, this has to be U4, and this has to be U5. So the fifth term means U1 plus n minus 1. 5 minus 1 times D. The fifth term is 31. U1 is 7 plus 4 times D. So what does that 4D becomes? 31 minus 7. What is 31 minus 7? 24. So D equals to 24 upon 4. So what is the value of D? D equals to 6. Once I come to know about the common difference, then I find A. A is nothing but what? U1 plus 6, which is nothing but what? 13. B is A plus 6 because the common difference, which is 13 plus 6, which is 19. And C is B plus 6, which is 19 plus 6, which is 25. That's going to be the answer. Question number 2. He says the first two terms of arithmetic sequence are 6 and 10. So U1 equals to 6, U2 equals to 10. Write down the common difference. Common difference is U2 minus U1, which is 10 minus 6, which is 4. Determine the expression for the nth term. Nth term, so U1 equals to U1 plus n minus 1 times D, which is 4, which is 6 plus 4n minus 4, which is nothing but what? 4n plus 2. For the smallest term in the sequence, which is greater than 200, determine the value of n and tn. So, which term is greater than 200? 4n plus 2 is greater than 200, the smallest one. So, what does that becomes? 4n is greater than 198, n is greater than 198 divided by 4. So, n is greater than 49.5. 49.5. So the smallest term is going to be nothing but what? N is 50. So what is that 50th term now? 4 times 50 plus 2, which is 200 plus 2. U50 equals to. So which is nothing but how much? 202. That's going to be the answer. Question number 3. Both the first term and the common difference of arithmetic sequence are positive integers. The 14th term of the sequence is 4 times the third term. 14th term is 4 times the third term. So 14th term is U1 plus 13D is 4 times the third term, U1 plus 2D. So what do I get from there? U1 plus 13D equals to 4U1 plus 8D. So 5D equals to 3U1. So what am I going to get it out? U1 equals to 5D upon 3. Determine the smallest possible value of the first term and the corresponding common difference. So now I came to know that what is this? U1 is 5 times of 3 and they are positive integers. So therefore D has to be nothing but what? The smallest integer is going to be D has to be 3. If D can be 3, then 3 can be cancelled and I can get it out 5. You can take D as 6 also, but it will be the next highest number. But he's asking the smallest one. You can take D as any multiple of 3 so that you get an integer when you simplify that. So the least multiple of 3 is going to be 3 itself only. So therefore, what am I going to take? Common difference as 3. In that case, the first term is going to be 5. See, these are both integers. So you have to take a D which is a multiple of 3 so that I can simplify and get that answer. Next, question number 4. The sequence A7BC25 is arithmetic. Find the values of ABC. A7BC25. U1, U2, U3, U4, U5. So find the values of ABC. So U5 is 25 equals to U1 plus 4D, 4 times of D. What is U1? U1 is A. So will that be sufficient for us to solve it out? A plus 4D. So we could not able to get that one. Now Another way what we can do it, difference between these two is the common difference. So D equals to U2 minus U2 minus U1, which is 7 minus A. So I can plug it out over here. So 25 equals to A plus 4 times D. D is 7 minus A. So 25 equals to A plus 28 minus 4A. So 25 equals to 28 minus 3A. So 3A equals to 3. So A equals to 1. Once I get the value of A, then D value is 7 minus A, which is 7 minus 1, which is 6. So I got it out. D as 6. So what does that B will become now? B equals to 7 plus 6, which is equals to 13. And C equals to B plus 6, which is equals to 19. So I got the value of A, B, and C. Question number 5. The first three terms of the arithmetic sequence are 55, 51, 47. 55, 51, and 47. Write down the next three terms. So we can see it is decreasing by 4. So next one will be 43, and next one will be 39, and the next one will be 35. Next, determine the expression for the nth term. So nth term means un equals to u1. u1 is nothing but what? 55 plus n minus 1 times d. d is negative 4. So what does that becomes? 55 minus 4n plus 4, which is nothing but what? 59 minus 4n. Then hence determine the value of the smallest positive term. So what should be the case? 59 minus 4n should be greater than 0. So 59 is greater than 4n. So n is less than 59 upon 4. So n is less than 14.75. 14.75 means 14. So I take it as 14. Then what is the term? Smallest positive term. Anything which is less than 14.75 is going to be a positive term. It can be 14, 13, 12, so on. But the smallest one is going to be nothing but 14th one. So plug in 14. 59 minus 4 times 14. So which is going to be 3. That's going to be the answer. Question number 6. The sum of first 10 terms of arithmetic sequence is 100. The sum of next 10 terms is 300. Determine the first term of the sequence and the common difference. Sum of what is this 10 terms? Sn formula. We are going to use Sn equals to n upon 2, 2 times of u1 plus n minus 1 times d. So I'm going to use that formula. So 100 equals to 10 upon 2, 2 times of u1 plus 10 minus 1 is 9d. This is going to be the way. So 20 equals to 2u1 plus 9d. That is the first one. So now the next one is nothing but what? Sum of next 100 terms is going to be, what is that? It is, how should I be able to find it out? So we will be finding it out. The sum of next 10 terms is 300. So 300 equals to 10 upon 2 times 2u1 plus next 10 terms is 300. So totally it's going to be, what am I going to do? Instead of doing this formula, I will be writing it out over here. Sum of next 10 terms is 300. What does that mean? Sum of total this 10 terms over here and 10 terms over here, 20 terms, is going to be 300 plus 100, which is 400. So 400 equals to 20 divided by 2, 2u1, 20 minus 1 is nothing but what? 19, 19d. So what does it becomes? 2 times 1, 2 times 10, 40. 40 equals to 2u1 plus 19t. So I got the other equation. What was the other equation? 20 equals to 2u1 plus 90. Subtract it out. 20 equals to 10d. 10d. So d equals to 2. So plug in d equals to 2. 20 equals to 2u1 plus 18. So 2u1 equals to 2. So u1 equals to 1. Question number 7. Prove by induction n factorial is less than or equal to n power n. So basis step. N equals to 1 for the left hand side. It is 1 factorial, which is 1. For the right hand side, 1 power 1, which is 1. So therefore, let this be Sn. Sn is true for n equals to 1. Now assumption. Let us assume that k factorial is less than or equals to k power k. Now we have to prove that it is true for n equals to k plus 1. So n equals to k plus 1. So what am I going to take? K plus 1 factorial. And I have to prove that it is less than k plus 1 to the power of k plus 1. How can I write k plus 1 factorial? I can write k plus 1 factorial as k plus 1 times k factorial. K plus 1 times k. So how should I be able to get this one? Carefully we see. Now we know that our assumption. What was our assumption? K factorial is less than k power k. So I bring this one over here. We do some homework over there. So we know that k factorial is less than or equals to k power k. So what can I do? I multiply by k plus 1 on both sides. So what do I get it out? K plus 1 times k factorial is less than or equals to k power k times k plus 1. So I can write this is less than k plus 1 times k power k. This will be obviously less than k plus 1 times k plus 1 to the power of k, because I'm replacing k with k plus 1. So obviously it will be less than the next number. This is by logic. So now this is power 1 and the bases are equal. So power should be added. K plus 1 to the power of k plus 1. So over here what I have done it out? It's logic. 2 power k will be always less than 3 power k. 4 power k will be always less than 5 power k. If at all k is a positive integer. So k power k is always less than nothing but what? K plus 1 whole power k. So I have just replaced by using that basic logic. Now the bases are equal. Power should be added. I get it out. K plus 1 to the power of k plus 1. So by principle of mathematical induction, it must be true. Don't forget to write. It must be true for all positive integers. Next, question number 8. Show that this is divisible by 15. So plug in basis step n equals to 1. So it becomes 4 power 3 plus 5 power 3 plus 6 power 3. So what do I get it out? When I do 4 power 3 plus 5 power 3 plus 6 power 3. So I can take the calculator and do 4 power 3 plus 5 power 3 plus 6 power 3, which gives me 405. Is 405 is divisible by 15? Yes, it can be written as 15 times 27. So therefore it is divisible by 15. Now assumption. 4 power 2k plus 1 plus 5 power 2k plus 1 plus 6 power 2k plus 1 equals to 15p. Now we can make anything 1 as a subject. So what am I going to take it out? I am going to take 4 power 2k plus 1 as subject. It becomes 15p minus 5 power 2k plus 1 minus 6 power 2k plus 1. Now I have to prove that 4 power 2k plus 1 plus 1 plus 5 power 2k plus 1 plus 1 plus 6 power 2k plus 1 plus 1 should be divisible by 15. So for that, what am I going to do? It becomes 4 power 2k plus 1 plus 2, 5 power 2k plus 1 plus 2, 6 power 2k plus 1 plus 2. Now it becomes 4 square times 4 power 2k plus 1 plus 5 square, 5 power 2k plus 1 plus 6 square, 6 power 2k plus 1. 4 square is 16, 4 power 2k plus 1 is 15p minus 5 power 2k plus 1 minus 6 power 2k plus 1 plus 25 times 5 power 2k plus 1 plus 36 times 6 power 2k plus 1. So what can I do that one? 16 times 15p minus 16 times 5 power 2k plus 1 minus 16 times 6 power 2k plus 1 plus 25 times 5 power 2k plus 1 plus 36 times 6 power 2k plus 1. Now we can see these two are like terms and these two are like terms. So it becomes 16 times 15p minus 5 power 2k plus 1 common means 25 minus 16 is nothing but what? 9 plus 9 times 5 power 2k times 5 power 1 because I want to take 15 common, that is the reason. And for 6 power 2k, 36 minus 16 is nothing but 20. 20 times 6 power 2k times 6 power 1. Now I need to see that I can take 15 common. So it becomes 16p. 15 means 3 times 5. 5 from here, 3 from here. So gone. It will be 3 times 5 power 2k. Again 15. 5 times from here, 5 times 4 and 3 times 2. 3 from there. So it will become 8 times 6 power 2k. So which is multiple of 15. So I'm trying to take 15 common. How is that I have done? 9 times 5 is 45. 45 times 3 is 15. 20 times 60 is 120. 120. 15 times 8 is 120. That's going to be the way. So therefore it is divisible for all the integers. Now lastly, question number 9. So first write the statement. So substitute r is 1 to n. So 1 cube plus 2 cube plus 3 cube plus and so on plus n cube equals to n square times n plus 1 whole square upon 4. So now first left hand side basis step. 1 cube which is 1. Right hand side 1 square 1 plus 1 whole square upon 4 which is also 1. So therefore the statement is true for n equals to 1. Now let us assume do the assumption step. So 1 cube plus 2 cube plus 3 cube plus and so on plus k cube equals to k square times k plus 1 whole square upon 4. Now I have to prove for k plus 1 whole cube. 1 cube plus 2 cube plus 3 cube plus and so on plus k plus 1 whole cube. So before term would have been k cube. So this entire thing is assumption. So it becomes k square k plus 1 whole square upon 4 plus k plus 1 whole cube. So what is missing? 4. So make the common denominator 4. So it becomes k square k plus 1 whole square plus 4 times k plus 1 whole cube. So what can I take common? K plus 1 whole square common. So I'm left over with k square plus 4 times 1 more k plus 1 upon 4. So what does that becomes? K plus 1 whole square times k square plus 4k plus 1 upon 4 which is k plus 1 whole square times k plus 2 whole square upon 4. That's going to be the answer. So because when I plug in k plus 1 in the right hand side also, I should be getting it out k plus 1 whole square times k plus 2 whole square upon 4. So therefore by principle of mathematical induction, it must be true for all positive integers of n. So that completes this worksheet based on series and induction. See you in the next video. Bye.